The project manager is divided into individual sections that can be accessed from the left side panel. The first one is project specific. You can browse your local machine for existing project, select a recent project from the list, create a new blank project, or create a new project using a default template. The second tab is dedicated to learning resources, tutorials, help, documentation, and live support. To jump straight to any of these links, simply click on it and your default browser will do the rest. You can quickly gain access to our video tutorials, YouTube channel, exchange with the NRG community by accessing the forums, ask a question online using our Q&A platform, or simply get live help through our Discord server. The last two links are connected to dedicated resources, one for the NRGeditor manual and the other for the NRG API documentation. Right under Learning is the Microgames section. This section will allow you to download and automatically open any of the games listed here into the NRGeditor. We currently have available for download a karting game, a 3D platformer, and a first-person shooter. Below each of them, a link to a comprehensive live presentation is available. Following that presentation online will teach you step by step how to build that microgame from scratch. The next section is the demo project section. Similar to microgames, you can directly download and open the project inside the NRGeditor. The first one is a sandbox that contains a PBR renderer to get you started with your project. The next one available is a modern showroom where you can learn, preview, and test in real time the usage and behaviors of each type of objects available by default in NRG. The last one is a link to a published demo, which is a real-time path tracer / benchmark that demonstrates the capability of NRG. Feel free to download it and run it on your desktop. Take note that the full project, including its source code, is available for free to all registered users. The last section is dedicated to publishing. With the proper credentials, you can use our built-in one-click mechanism to properly package your application and generate a C++ project for all major mobile and desktop platforms. Your project will be pre-compiled, fully optimized, and compressed, resulting in a compact NRG package. In a nutshell, an NRG package, or NPK for short, is a compressed cross-platform 64 bits local file system that contains all assets and resources of a project. It is designed to be portable, secure, feature real-time decompression for lightning-fast loading of assets and resources. It also provides quick direct random access for asset lookup. Now let's start exploring the default layout underneath the project manager. Let's head back to the microgames section and download Microland and load it into the NRGeditor. When you create a new project, or like in this case load an existing one, you'll land on the default layout, which is divided into individual dynamic sections. The top bar is where the default menus are located, application playback controls, and layout selector. The View 3D, located in the center, is where you can preview your application output and edit the dynamic aspects of your scene. On the right side, you have access to generic properties and settings ranging from the one available for the different subsystems to the one based on your current object selection and common assets. The next tab in this section is the outliner. The outliner is a 2D representation of your current scene active in the View 3D. In the lower area, you have access to the library. The library is where all project assets and resources are located. You can operate the library just like a file explorer, at the exception that you'll be creating asset groups as folders and manipulate asset files. The next tab is the console. It displays all interaction of the NRGeditor with the command server, as well as the status of each individual local threads. Now that we had a quick overview of the default layout, let's have a closer look at each individual section. The top bar is visible at all time regardless of the layout selected. It contains the default NRGeditor menus, playback controls, and layout controls. The empty space is context specific and will be allocated based on the current editor selected. If I select this one, it gets extended. If I select this one, it gets updated or cleared if no context menu is available. The base of each menu can also be collapsed or expanded to show only the information that you need. It is especially useful if you're running the NRGeditor on a mobile tablet, since some editors can have quite lengthy amount of menus and numerous option buttons. At the top right corner, you have access to the quick playback controls. You can use them to run and playtest your application. Simply press play to start or shift play to save your project before launching it. Once your project is running, you can use any of the viewports available to send inputs from mouse, touch, keyboard, or gamepad. At any time, you can pause and step frame by frame. The sound button can be used to turn on or off the volume of your application. And if you wish to simulate a full screen experience, you can simply press here. To get back to the NRGeditor once you are in full screen mode, simply press the escape button. To stop the execution of your project, you can simply press the stop button. And your application will be restored to its last save point. At any time, if you want to debug your scripts, you can control the state of the debugger by pressing the little bug here. Once a breakpoint is activated, the integrated Lua debugger will break and switch the focus to your source code or the equivalent node. From there, you'll be able to use the debugger control to debug it. Finally, located on the far right of the layout is the selector. In this section, you can quickly change the specialized workspace you're working on based on the work at hand or create your own by pressing New Layout. Part of the default layout and one of the main areas of interest is the View 3D. It can also be found on other specialized layouts, mostly due to its versatility. Its primary goal is to give you the control you need in order to edit your scenes and implement the dynamic aspects of your project. From the top left toolbar, you have access to two tabs. One to show the active viewport properties, and the other to access the navigation and pathfinding tools. Next, you have the timeline playback controls, which also can be found on other editors. They allow you to simulate the execution of your scene without actually starting your application. The center area is dedicated to viewports. Take note that the View 3D is not meant to be a level editor per se. 3D authoring softwares are really good at that, since at its core, NRG gives you the flexibility to build your own engine and renderer. There is no predefined linear workflow. Scenes or levels are usually assembled in an external 3D software and imported into NRG based on a customizable sets of rules, which lead us to the render control of the viewport. NRG is built on a unique approach based on what we call render layers. A render layer is similar to a typical layer found in graphics manipulation software. The exception is that it is in fact an actual GPU-based render pass, 100% customizable. You can choose to draw directly on the OpenGL back buffer or on an off-screen frame buffer using a fragment shader or a compute shader. As a result, a typical NRG application consists of multiple render layers or rendering passes. For microLand, these are the current render layers that have been manually implemented to achieve the final image of the application. If we access the first one from the list, the right depth, this render layer draws different sections of the scene using probes. Each mesh are connected to a GLSL shader that simply write the depth into a layered frame buffer used for shadowing in the next pass. The next pass is for opaque geometry. In this pass, each mesh are connected to a different material that are linked to a custom GLSL PBR shader in order to compute the shading. Next, we compute multiple post-processing effects off-screen using specific shader, but this time we're using a full-screen quad. We have screen space ambient occlusion, bloom, screen space reflection, motion blur, and depth of field. Once we got the result of each of these render layers, we can then compose the final image and draw it on screen. Once a render layer is in edit mode, you can change the shading of the viewport using the shading widget. You can choose between shaded, wireframe, or shaded and wireframe. To switch between the viewport camera and the render layer camera, if any, you can press here. In this particular example, the shading data is written to an off-screen frame buffer, but we can still view the geometry information using wireframes. The default action of the left mouse button is set to selection. The mode of the left mouse button can be controlled by the options up here: pan, rotate, or zoom. You can focus your active selection using the view menu or dot on your keyboard. Next, to zoom, you can access the navigation edit mode, and here you can change the pivot point of the grab mode. The grab mode can be activated by pressing G and holding the G key on your keyboard and allow you to move and place objects around your scene. With the viewport selected, simply grab by holding G. First-person controls are activated by holding the right mouse button to move the view, and you can navigate using WASD and RF to go up and down. As you notice, once the viewport has an actual selection, the 3D manipulator is available. You can change the manipulator mode using these option buttons between translate, rotate, and scale, or hold shift to create combination. To increase or decrease the size of the manipulator, with the viewport selected, you can simply press plus or minus. To enable or disable the manipulator, press here. And to change the orientation of the manipulators from world space to local space, you can press here. Before we wrap up this quick introduction of the View 3D, to get help about any type of widget on screen, you can select it with your mouse and then press Ctrl-Shift and push the left mouse button. The default browser of your operating system will open up and load directly the help section associated with this widget from our website. On the right side, you have access to Properties and Outliner. Under Properties, the first section gives you access to Subsystem and General Setting. In the first tab, you got the Application Settings. The second one, you have access to the Sound Engine Settings. And next, the Physics Engine Settings, only available if a physics engine has been specified in Application Settings. If you notice, no scroll bar can be found inside the NRGeditor. To scroll any tab bar, panels, list, text areas, all you have to do is to left-click on any empty or disable widget of the interface, then simply drag. To reset any drag offset, simply double-click. Alternatively, you can use right-click to select the underlying widget at the exceptions of spinner. Right-click and drag on the spinner widget will allow you to change its value. You can also speed scroll by holding Shift while dragging, giving you quick access to properties. You can also change the order of the different slot boxes using a simple drag and drop operation. Allowing you to customize the properties layout to your liking. The next section is scene specific. The first tab gives you access to properties and settings of the active scene selected inside the application settings. You can change the scene currently active in the View 3D by accessing the scene list and selecting a new entry. In here, this is where you have access to render layer setup and more. We talked previously about render layer setup. If we take a first one, in example, the right depth, as you can see, it is labeled as a probe pass. No camera and no material have been specified. This pass is a depth-only pass that directly draws off-screen using probes. Next, the geometry pass that we observed earlier in this quick start session is built slightly differently. As you can see, this time a camera is connected to the render layer. Each material connected to the geometry in this pass are independent, and their result will be written to the frame buffer linked to that camera. If we jump directly to the screen space ambient occlusion pass, this pass is connected to a camera and a material. This time, the pass is drawn on an off-screen quad and its result will be stored on a frame buffer associated to that camera. This pass does not contain any actual geometry and is simply using a full-screen quad. This is just a glimpse of the actual kind of setup that you can create manually based on your application and project requirements. Take note that we are only scratching the surface here, and more options and configurations are available. In this example, all the GLSL shader code, frame buffer setup, as well as the rendering sequence have been manually engineered. The next tab is dedicated to navigation and pathfinding properties, only available if a navigation engine is selected. These are the navigation and property settings. The next section is context specific based on the active object selection. Here, we got the default object properties. Next, the properties available based on the type of object. Like in this case, a static mesh is selected. If I access the geometry render layer, zoom in and change my selection to here, which is a skeletal mesh, we can see that the type of properties change. Next, we have the object transformation constraint, which is common to all object type. We got the object sensors that allow you to detect other objects in proximity, mostly used to create triggers. Physics properties to make the object interact inside the physics world of your application. Material that is based on the current object primitive selected or can be manually selected from the list. To restore to automatic selection, press the clear button. And if I select here, we're going to see that I select the land dirt material, and up here, the land grass material. Same goes for the physics material of the selected primitive of the object. The last two tabs are common asset properties. First, we got the audio effects. And next, we got armatures. Armatures are used to create skeleton masks that can be used during action playback or with action controllers. Next, we have the outliner. The outliner is a flat representation of the objects contained in your scene. You can directly select an object from here, or observe the current selection, change their state, execute search query for the entire scene or on a per object basis. At the bottom of the default layout, you can find the library and the console. The library is where all the assets and resources of your projects are located. It allows you to create an asset, once the library is selected, you can simply drag and drop assets from your operating system file explorer, and the NRGeditor will do the rest. You can import textures, sounds, shaders, script, individual 3D assets, or an entire scene, just to name a few. Take note that similar type of integration is also available between the library and the View 3D. Based on the type of asset selected and dropped on the View 3D, the asset will be either loaded, automatically create a new object, or get connected to another type of asset. In example, if I select the geometry render layer and access the microland meshes, if we zoom in, place my 3D cursor, if I drag and drop this object here, it's going to create me a static mesh. If I select, in example, a sound buffer, drag and drop it, I got a sound source that is created. Same goes for materials. If I select a different material from the list and simply apply it on a primitive, it is directly applied. The same concept also applies to textures, scripts, shaders, and more. When you are working on your project in edit mode, the library is basically like a file explorer. You can create and store your assets into asset groups, in other words, folders, and individual asset, also known as files. The left side of the library is dedicated to asset group, and the right side to assets. You can use the tool button on both designated area to create a new asset group, rename the current selection, or remove the asset group. For the asset list, you can duplicate the current selection, rename the current selection, or delete the current asset. Let's create a new asset group. Select it. Now let's create a new asset of the type scene. And if we drag the scene onto the View 3D, the scene gets automatically loaded. If I access the first render layer, since we have now a scene currently active, during the import process, object will be automatically created in position. If none were available, imported asset would simply be stored in the active library path. Let's now import a scene. Select the library, asset, and import. And if I go on my desktop, I am going to load this GLCF file. Import, and automatically my scene and all the objects associated to it, textures and materials, are all loaded. Once assets are imported, you can use drag and drop operation to either move individual assets around or an entire group. In the asset list section, you can change the sorting method, the listing method, the preview size, and select the type of asset that should be displayed by the current library. However, the last icon in this row is not an asset, and only become active when a texture is selected and give you access to the texture compressor. The compressor will allow you to either compress texture individually or in batch. This time, let's import a texture using the operating system file integration. Select the texture and open up the compressor. In the next tab of the bottom section, we have the console. The main area of the console displays all the scripting commands emitted by the NRGeditor to the core server. Active threads are listed on the left, displaying their current state, which can be either idle, active, stopped due to an error, or hooked by the integrated Lua debugger. In addition, each thread also displays to which resources it is actually connected. The NRGeditor is not interacting directly with any of the NRG C++ API. All commands are generated by the editor and dispatched either locally or remotely to the active NRG context connected. This allows the NRGeditor to be totally independent of its underlying architecture and separated from the core API. This unique approach has great benefits and unlocks many possibilities that have never been seen before in a development environment. It removes all dependencies of the editor to the final product, allows real-time development on multiple devices simultaneously, ensure cross-platform compatibilities and performance across the board, allow establishing a real-time collaboration environment where multiple developers can work on the same scene at the same time, and it provides also a friendly access to version control systems. The lower section of the console can be used to send manual commands to a specific thread. That thread is determined from its selection state in the thread list. And if remote devices are connected, the command prompt can also be used to manually send commands to each devices. A similar mechanism is used internally by the debugger and the profiler to communicate with the remote clients. Take note that since all commands are deferred, the console is also a great learning tool. Each time you are interacting with a widget in the editor, the corresponding scripting command will be generated. Just by visualizing the console echo, you can not only learn a great deal about how to use the NRG scripting API, but also use the console as a scripting command generator for your ongoing projects. Hopefully this quick start session gives you a good overview of the NRGeditor and the ecosystem built around it. Take note that not all layouts available and specialized editor have been covered in this session. For more information, please visit our website to gain access to the full editor manual, API documentation, video tutorials, demo projects, live learning presentations, and more. Thank you very much for watching.